Hey everyone, and welcome. So picture this. You're running your applications on premises, but your security vault, your single source of truth, is in the cloud. You've probably run into this huge challenge. How do you manage secrets securely in that kind of hybrid world? Well, today, we're going to demystify CyberArk's Centralized Credential Provider, or CCP, which is the exact tool designed to solve that hybrid puzzle. So here's what we've got on tap. We're going to start with why hard-coding credentials is such a bad idea. Then we'll introduce the solution, the credential provider. After that, we'll really dig into the hybrid architecture, see how applications actually get their hands on secrets, and we'll even do a quick and dirty tutorial on safe permissions, which is a common stumbling block. We'll wrap it all up with the best practices you absolutely need to know to make your implementation rock solid. You know, this quote just hits the nail on the head. We've all seen it, right? Passwords just sitting there in plain text inside config files or deployment scripts. It's a massive and, frankly, totally avoidable risk. And think about it. When it's time to rotate a password, it becomes this mad scramble. And auditing who has access? Forget about it. It's a total guessing game. There has to be a better way. So that brings us to the big question we need to answer. How can our applications get the secrets they need exactly when they need them without us ever having to bake those secrets into the code itself? How do we get to that true, on-demand, super secure access? And the answer to that question? Well, you've probably guessed it. It's CyberArk's Centralized Credential Provider, the CCP. This is the bridge that solves that on-prem to cloud problem. The easiest way to think about the CCP is like a secure valet for your application secrets. Your app just asks the CCP for a password. The CCP then turns around, validates the app's identity, checks its permissions against the main cloud vault, and only then does it hand over the credential. The real magic here is that just-in-time delivery. The secret is never, ever written to disk on the application server. And that right there shrinks your attack surface down dramatically. All right, let's pop the hood and get into the architecture. How does this whole thing actually work when your vault is living up in the CyberArk cloud, but your CCP is sitting in your own data center? What's really cool here is the clear division of labor. Your main vault, the brain of the whole operation, is up in the CyberArk cloud, handling all the heavy lifting of storage and policy. Then, on your on-prem network, you have the CCP itself, which is really a web service running on a Windows IIS server. This is the front door for your apps. But the real workhorse is the agent service running on that same server. That's what talks to the Cloud Vault and manages a secure local cache. And the glue holding it all together? That's the provider user. It's the special identity the CCP uses to prove to the vault that it's legit. So, the request flow is actually pretty straightforward, but it's incredibly powerful. Your app says hello to the on-prem CCP and proves who it is. The CCP then reaches out to the Cloud Vault to validate that identity and check its permissions. If everything looks good, the secret is delivered securely over HTTPS, and the entire transaction gets logged. It's clean, it's secure, and it's 100% accountable. If we zoom in on the CCP server itself, there are two key pieces working in tandem. First, you've got the AIM web service. That's the public face, the API endpoint running an IIS that your applications actually talk to. But the real intelligence, all the heavy lifting, is done by the CyberArk Application Password Provider. That's the background Windows service that manages the secure connection to the cloud, maintains that encrypted local cache, and makes sure all the secrets are synced up. Okay, so we know the app makes a request. But how does the CCP know it's a legitimate application and not some imposter? Let's break down how they actually prove who they are. You've basically got two main choices for authenticating your application. The first one is simple: IP address or hostname. It's super fast to set up, but let's be honest, it's not great for dynamic environments, and it can be vulnerable to IP spoofing. For much, much stronger security, you've got mutual TLS, or MTLS. With MTLS, both the app and the CCP present cryptographic certificates to prove their identity. It's a trusted, two-way handshake. Yeah, it takes a bit more work to set up a public key infrastructure, but it is absolutely the gold standard for security. Once the app is authenticated, it just makes a simple REST API call to get the secret. You absolutely have to provide the application ID. But listen, here's a super important pro tip. Always, always include the safe name in your request. Why? Because if you don't, the CCP has to search through every single safe that app has access to, which can really slow things down. Specifying the safe makes the response way faster. You can also add the specific account name and a reason for the request, which is awesome for your audit trails. Now, this is what your developers are going to see in response, so it's really important to know what these codes mean. A 200 OK, great, you got the secret.
But here's a common point of confusion: the difference between a 401 and a 403. A 401 unauthorized means you couldn't even get in the front door. Your cert was bad or your IP wasn't allowed. But a 403 forbidden is different. That means you got in, you're authenticated, but you didn't have the right permission to get the specific secret you asked for. And that brings us to our next topic.
Okay, let's switch gears and do a quick little tutorial. This is probably one of the most common things people get tripped up on: the difference between list, use, and retrieve permissions inside a CyberArk safe. Getting this right is crucial.
First up, we have the list permission. The best way to think about this is like looking at a phone book. You're allowed to see that an account exists. You can see its properties like the username or the server address, but you absolutely cannot see the secret itself. No password for you.
Next is the use permission. Now, this one is specifically designed for human users who are connecting through the Privileged Session Manager, or PSM. It lets them launch a secure proxied session using a credential, but they never actually see the password. This is only for interactive sessions. The CCP is an API, so if your application only has use permission, its request will be denied. Simple as that.
And finally, the big one, the one we've been waiting for: retrieve. This permission is the golden ticket. It allows an identity, whether it's a person or an application, to see, to copy, and to programmatically fetch the actual secret in plain text. This is the key. Your application ID must have the retrieve permission on any accounts it needs to fetch through the CCP. This table here really brings it all home. List lets you see that an account exists. Use lets a person launch a session with it, but only retrieve lets you actually grab the plaintext password. So for the CCP to do its job, the answer is always, always retrieve. That's the one that unlocks programmatic access. End of story. Okay, so now that we know how it all works, let's talk about how to do it right. We need to build this thing to be resilient, to be scalable, and to be absolutely rock solid. Look, the CCP is going to become a critical piece of your infrastructure, so you absolutely can't let it be a single point of failure. The strategy has 3 key parts. First, put multiple CCP servers behind a load balancer. That gives you scale and redundancy. Second, configure transparent failovers so your CCPs can automatically connect to a DR vault if there's a major outage. And third, and this is so important, leverage the persistent cache. This cache lets the CCP keep serving secrets even if the network connection to the cloud vault goes down for a bit. It is your safety net.
All right, I want you to burn this number into your brain: 50,000. This is the maximum number of accounts that a single CCP should ever be authorized to access. If you try to push past this limit, you are going to have a bad time. You'll run into memory issues and major instability. It's a critical performance ceiling, so please respect it. Let's quickly run through a playbook of the do's for a great CCP implementation. First, do always include the safe name in your API calls for a massive performance boost. Second, do use dual accounts for your most critical applications so you never have downtime during a password rotation. Third, do keep an eye on how many apps are hitting a single CCP node. Try to keep it under 500. And finally, do lock down the IIS service account with the absolute minimum permissions it needs to run. And of course, now for the don'ts, the common traps you want to avoid. First, as we just said, don't authorize a CCP for more than 50,000 accounts. Second, if your load balancer is handling the SSL, don't forget to configure trusted proxies. If you miss this, the CCP won't know where the request is really coming from, and your IP authentication will break. Third, whatever you do, don't disable the cache. It's essential for both performance and availability. And finally, don't run the scripts or applications calling the CCP with admin rights. Least privilege always. So as you can see, the CCP is so much more than just another tool. It's a real strategic enabler. It's a game changer. It allows you to build automation that's more secure, more compliant, and way more scalable because it truly decouples your secrets from your code. And that really leaves us with one final thought. Now that you have this power, what's the very next application you're going to secure?